Hello everyone, welcome to my YouTube channel, Effective Coder. Today I'm solving Leetcode question 743, Network Delay Time. You are given a network of n nodes, labeled from 1 to n. You are also given times, a list of travel time, as directed edges. So times I has three components, U, V, and W, where UI is the source node. Vi is the target node, and Wi is the time it takes for a signal to travel from source to target. So basically, source node U, target node V, and then W represent the time it takes to travel to the target node V from the source node U. So we send a signal from a given node K. The starting node is our K. That's the starting node for the signal. Return the minimum time it takes for all the n nodes to receive the signal. If it's impossible for all the n nodes to receive the signal, return -1. So basically, we have a starting node, K. So in this example, our K equals to 2. So our starting node is node 2. So basically, we want all the nodes to receive the signal. So we want the signal to travel from 2 to 1, 2 to 3, and also 2 to 4. So, and then we for each path, basically each path denotes, let's say, from the signal 2 to signal 1, there is one path. From signal 2 to signal 3, there is one path on the graph. So it has a travel time of 1. There is only one path to reach node 4 from node 2. So basically, you first go to the node 3, and then from 3 to node 4. So the total travel time is 2 units. So let's suppose we are adding an imaginary path on this graph. So in that case, there is a direct edge connecting node 2 to node 4, and then we assign travel time 3 to that imaginary path. And then now we have two possible ways for the signal to reach the node 4 from node 2. One is from the directly connected imaginary path that we just added. The other one is first travel to node 3 and then from node 3 to travel to node 4. So which one is the shortest? So the real path that's displayed on this graph has the shortest path. So in that case, the minimum time it takes for all the n nodes to receive the signal is still 2. Basically, we want to find the time it takes for the signal to reach the bottleneck node, which means the node that it takes the longest time for the signal to reach. And then if there are multiple paths to reach the bottleneck node from the starting node, we want to choose the shortest one. In that case, we will just return the minimum time. So that's kind of this problem statement. So what is the idea for solving it? You can tell it's a shortest path problem, and then it can be solved utilizing a very popular algorithm called Dijkstra's algorithm. It's one of the very popular graph algorithm. So the main idea for solving it is we first construct the dictionary of each node and its neighbors. Basically, for each node, we want to keep track of what are the neighbors it can reach. So from 2, the neighbor is the neighbor of 2 are node 1 and node 3 because there is a direct edge to connect from node 2 to node 1 and from node 2 to node 3. And then we also want to keep track of the travel time from each node to its neighbor. And then we also want to keep track of a mean heap. So in this mean heap, it keeps track of the time to reach node V from starting node K. So it has two components in this tuple. First element is T. That's what this mean heap is sorted based on. So this mean heap is sorted based on the time T. And then every time when we try to pop an element from this heap, it pops from the top of this mean heap, which is the minimum element. And then our sorting criteria is the first element in this tuple, which is the time T. So remember, this T is the time to reach node V from the starting node K. So basically, every time when this heap pop an element, it pop the shortest path from all the existing paths in this heap. So if there is let's say if there is multiple paths to reach node V from node K, and then they're all stored in this heap. When we are trying to pop from the top of the heap, we pop the one with the shortest path. So to implement the dictionary, we utilize the default dict. And then for the min heap, we utilize the default implementation in Python that's called heapq. So basically, we utilize to import two libraries, the default dictionary and then the heapq. So let's try to start coding. So in this case, let's first construct the paths. So we have the dictionary. Path equals the default dictionary of list, because each node can have multiple neighbors. So for the u, v, w in times, path u equals path u dot append our node v and then the weight. So basically, for each node u, we keep track of all the neighbors that's connected by a direct edge, and then also keep track of the travel time from node u to node v. We also want to keep track of the time. So let's say travel time equals 0 initially, and then we want to utilize a heap. So basically, initially this heap has the 0 and the k. So 0 means it takes 0 time for the signal to reach the node k from the starting node. Remember, node k is also our starting node, so it takes 0 time for the signal to reach itself. And then we also want to keep track of all the visited nodes. Because we are utilizing a min heap, so the path to reach node V that's popped from this heap first is the shortest path. And then if we have some other path that's already that also reach the node V, it will have the longer travel time if it's popped later. So in that case, we want to keep track of all the nodes that the signal already reached. So we utilize a set to keep track of that. So while heap, so if we have these elements in this heap, we just pop it. So the weight and then the node u equals heap q dot heap pop. And then we check if this has already been visited before. If u in visited, if you already visited, we just go to the beginning of this while loop and try to pop the next element from the min heap. If it is visited, it means the signal already reached the node u. Okay, if this node u has not been visited before, we add it to the visited. And then we are trying to update the total time. So the travel time equals the travel time equals the maximum of the travel time and also the time to reach the node U from the beginning. Let's say, for example, this travel times previously denotes the time it takes to reach node 1. So from node 2, so that's 1. And now we are visiting the node 4. And then in that case, we have a longer path. The time is 2. So in that case, utilizing this logic, we are just updating the travel time. Eventually, this travel time will be the time it takes from the starting node to the bottleneck node. And then we consider all the neighbors. For V, W, U, V in path U. If this V not in visited, then we just add to the heap. So the travel time from starting node to node U plus the travel time from node U to node V is the travel time from starting node to node V. So we just add that to the heap. So in the end, so if the length of the visited equals n, it means the signal has reached all the n nodes. So we just return the travel time. Else, in that case, we just return -1. We cannot reach all the n nodes from the starting node. So let's run the first test case. Okay, let's try submitting it. Okay, it accepted. So when I first code up this problem, I forgot to keep track of the visited. So basically, I forgot to check here if this node U has already been visited before. And then I failed one test case. So now I'm just going to utilize that as an example to how to debug that during the coding interview. So basically, during the coding interview, after you code up the solution, you will try to find out a few test cases yourself, and then to test it. Sometimes the interviewer, they came with a set of test cases they already have in mind, and then they will ask you to check that. So what if your code fail one of the test cases? So basically, you are just trying to input the test case and then walk through the code execution line by line. Basically, you are just trying to describe it and verbalize the execution results. So I'm going to show you how to do that. Let's say in this case, if now checking if U is visited, let's suppose my code forgot these 2 lines. And then it failed this test case. So in this case, the input is this time, and then we have the n equals 3, k equals 1. Starting node is node 1. It's a very simple test case. Our program output is 3, but the expected output is actually 2. So it's actually pretty simple if you draw out this on the paper. So then we are trying to execute it line by line. So basically, let me put it in a document. Okay, so I'm trying to show it in parallel so that I can show you how it's executed. Okay, so basically this is my code, and then this is my test case. I'm just going to walk through the execution process. So for example, for that test case, I first, by executing the path, creating the path, and then after executing those 3 lines, I have a dictionary called path, and then the key, let's say, for 1 is 2 and 1. So let me copy paste the input as well. So in that case, the path, so from node 1, you can travel to node 2, and then the travel time is 1. From node 1, you can travel to node 3. The travel time is also 2. Is 2. The travel time is 2. And then from the node 2, you can travel to node 3, and then the travel time is the travel time is 2. So in that case, you create the dictionary path correctly. So finish checking those 3 lines. And then you just do some initialization here. So basically, your original heap is 0, 1 as your k equals 1. And then the visited is just an empty set at the very beginning. And then in the first iteration, there is only 1 element in the heap. You just pop it. So in that case, so my W, the time to reach the node U from the starting node is 0. My node U is node number 1. And then we add this node to visited. Remember, in this code with arrows, I forgot to include the line 29 and 30. So the 2 lines I commented out. So in that case, the next step is just directly add this node 1 to the visit set. Visited.add. This equals 1. And then in that case, my travel time, the total time, is 0. Because it's maximum of travel time, maximum of 0, and then the initial value for this W. So it's 0 and 0, so the travel time equals 0. And then I execute those 3 lines. So basically, I check all the neighbors. So from the node 1, my neighbors in this path array are node 2 and node 3. And then I add the travel time and then the node into this heap. So now my heap contains those 2 elements, those 2 tuples. And now I go back to the beginning of my while loop. So in the second iteration, so the first element popped from this heap. Remember, we have a min heap. So the first element popped from the heap is the top of the heap, which has the smallest travel time. So in that case, it's 1, 2. So the travel time is equals 1, and the node is close to 2. So it takes 1 unit of travel time to reach node 2 from node 1. So in that case, I add node 2 to visit set. So my visit now contains node 1 and node 2. And my total travel time, is being updated because it takes 1 unit of travel time to reach to the node 2 from the starting node. So it's being updated. And then I check all the neighbors for node 2. So node 2 has 1 neighbor. So I add that to the heap. So in that case, the heap contains 2 tuples. And then I go back to the beginning of the while loop. So that's what I call my iteration 3. So in this one, it pops from the beginning of the heap. So from the top of the heap, which is the tuple with the shortest time. So in that case, it pops W equals 2, U equals 3, the node 3, travel time is 2. So the travel time from the starting node to the node 3 is just 2. And then you will realize that I actually made a mistake. So what mistake did I make? So I incorrectly described this one as the travel time. Never mind. So basically, the shortest time to reach node 3 is 2. So how did we derive this 2? This is actually carried from the first iteration. So basically, it takes 2 units of time to reach the node 3 from node 1, the starting node directly. There is another path that via the connecting node 2, but that has a total travel time of 3. So that's not popped in the iteration 3. So in this case, I got the total time of 2. because we compare and you take the maximum. And then now the heap only has one tuple left because there is no neighbor that's connected to the node 3. So when we try to exit this for loop, we are not adding any new elements into the heap. So now we are reaching our last iteration. Let's say in this iteration, we pop the only element left in this heap, which has the times 3 and then the node number 3. Let's say if we don't check if we have visited this U or not, we just continue executing, which means that okay, we add this 3 to visited, and then we keep updating the travel time. In that case, it will result in a wrong answer, which is the 3. So that's kind of what I got as the output, and then expect is actually true. So this is actually a very silly mistake I made, but I just want to utilize this process to show you, okay, when you finish coding, how to debug, and then sometimes most interviewer will also ask you to walk them through the code. So basically, the way to walk them through the code is just trying to take an example and then try to verbally describe the execution process by showing them, okay, what is the intermediate result after executing each block, how the data structure, the values inside those data structure, in this case, how the values inside the heap and the visited are updated, how is this like time, the travel time is updated as well, so that they will walk through the entire execution process and then have the final answer. So being able to describe the entire execution process in your own words, or just like walk them through the execution via the example is very important. Cool, so that's the end of my video. If you like my video, please subscribe to my YouTube channel. Thank you.